Okay, so I only got it for about a half an hour here, but I have a couple things I want to talk about, and then we'll be done. So we're not getting any homework or anything like that today. So just a few notes. So hopefully you have your notes out here in front of you. I'll give you your multiplication terms if you need it on your notes. Well, this might be a good day if you have a calculator out. You might want one today. We'll kind of discuss today. So, all right. Let me hand out your calculators. You might need these today. All right, there we go. All right. So, what we're going to be talking about today, we're on this section. Where is that? 5.2 to 5.3. What we're dealing with in this section is proportions. Proportions still. We have a couple things I want to discuss is the major uses for them. Okay. Now obviously the first thing I want to do, let's do a couple examples of what a proportion is. We're going to do a few of these, maybe two or three different examples on how to solve a proportion. So the main method that we talked about last Monday, I guess this past Monday, the main method that we use, number one, is called a cross product. So first method is a cross product. Now, what I call that in class, I think I call it aka fish method. Okay, it's called the fish method. That's the method that we use. Second one that we had, the second process, which I think I introduced Monday as well, was called scalar multiplication. And that was the one where you just have to use your multiplication chart if it works out perfectly. Okay, so those are the two. I want to do maybe an example of each or two examples. So these are ones that I want to make sure of. Now, the new stuff today, we have a couple different problems I want to talk about. And these are going to be based on the uses that we're going to use it for. Number one, we can compare ratios. So we'll use it for comparisons. So we'll compare two different fractions, see if they're equal or not. Okay? And I'll show you the process for that. The second thing I want to talk about today is actually doing conversions. Now, what I mean by conversions, not comparisons, conversion is when we're gonna be looking at either a map, money, bicycle. We'll look at things that we've looked at in the past. I think today we're gonna do money. I think, and we're gonna actually do some conversions where we take an object and we convert it to something else. So I'll explain once we get there. But let's jump right in the first part. Let's talk about a proportion in the first place. So let's say that my proportion is 6 over 11, and let's say that I was going up to, let's say this is 54, and I want an x here. And the goal here is to find what x is, okay? And we do it by two different methods. What?
What's the bottom number on 6?
11. Sorry, it must be at a weird angle together.
Yeah.
Okay, let's do this by cross product. Okay, so what number do we start with?
11.
Okay, you can start with 11. Okay,
It's 99.
either one. So you can either start with 11 or the 54. You're going to have to cross multiply these two together, and then what do?
Divide by 6.
Divide by 6, yeah. And what I always call this, fish method, because I always start with the number above or below x. You cross multiply like what you guys are doing, and then you divide, and it looks like a goldfish. That's why I call it fish method. But again, 54 times 11 and divide by 6. And what do you get? 54 times 11 and divide by 6.
99.
Okay, and that's my answer. That'd be the number on the bottom of that fraction. That's what I'm looking for. So it'd be 54 over 99. Now, that's one way to do that problem. Now, let me show you the other way. Because maybe you didn't like that. Maybe that to you didn't make any sense. I know a lot of you are really good at doing that, but let's say that didn't make sense to you. Here's another way to do it. I would like you to look at your multiplication chart now. So look at your multiplication chart. What number do you take times 6 to make 54?
9.
9. Okay, you take 6 times 9, right? That makes 54. So, now that you see that, 6 times 9 is 54, right?
Yep.
Take the bottom number, take 11 times 9, the same number.
99.
That's your answer.
Oh, wow.
So if you know what they're multiplying by to make the number larger, you can use that same number on the bottom. So you knew that they multiplied by 9, so you multiply the 9 on the bottom. It depends on the direction you're going. If you're going from big to small. What I mean by that, I'm going towards the x side. So I'm starting here, and I'm going towards x. Towards x. That's how I know if I'm dividing or multiplying. Okay, we're good with the first example.
Yeah.
Oh, yeah.
Okay, alright, let's do the second one. Second example, and now I'm going to pull one out of your book. So this might actually be a homework problem.
From yesterday?
Yep.
This way.
Okay.
I have to do something.
That?
No.
Or the old homework that I just assigned? I gotta put that up on the board too. Next example here. Okay, there we go.
Oh, that's the new one.
Okay, new one now. Walk me through it. What are you gonna do?
You take the 6 times 7 divided by 8.
Yeah, you cross, multiply, and you divide, right? Now, this number should not turn out very pretty. Agreed?
Yeah, it's 5.25.
Yeah. Weird numbers. 6 times 7, and then you divide it by 8. And you got the n or x, whatever the letter is. Now, say it again. 5.25.
Yep.
Let's talk about why it's a weird decimal, not a nice number like the 99 was. Here's why. Okay, 6, 8, n over 7. Here's why I knew it wasn't going to be a nice pretty number. I'm going towards the n. What do you multiply on an 8 to make 7? What do you multiply on an 8 to make the number 7?
1.
8 times 1 is what, 8? So it's not 1. It's a weird number lower than 1. So, since this number did not work out nice and pretty, right? You couldn't figure out a number that you had to multiply on the 8 to make 7. That is the same number that they were trying to multiply on the 6 up here. That's why I went from 8 to 7. It shortened up, so this number was going to get smaller. Now, it's not going to make a 5. It made 5.25. I can tell that it wasn't going to work out nice and pretty by the numbers that were chosen because I couldn't figure out what the multiplier was. So I knew it was going to be a decimal. Okay? All right, questions, comments about this style of problem, why it was a decimal? Okay, it looks like you guys have a pretty good handle on that. I think we had homework on that, what, Monday? We gave you homework that was due later this week. I think it's due tomorrow, I think. We had an assignment on that. In fact, let me pull that back up so we can actually see. That assignment was...
I already have it started. When you have it up there. You have it on the board.
No, this is the one I worked on Monday. It was 124, 1 through 5.
Oh,
And it was page 128, 1 through 5. I don't know if you guys turned that in or not. I'll have to look in my little stack here. But that's the ones that was based on proportions and simplifying fractions. So just make sure that that's what you're doing. You're just doing that cross multiply and divide on the second part here. The first part you just had to simplify the fractions. We talked about how to do that earlier. Okay, we good with the first style of problems?
yep.
Okay, now remember, that's due tomorrow. Keep that in mind, due tomorrow. Okay. So page 124, 128. Okay, I'm gonna leave that on the board. Let's go to the second part here today. We have to compare. So this is brand new stuff now. Brand new stuff, which I don't think is that difficult, but I want to show you a couple examples of what the book does. All right, so here's what the question in the book says. Are the two fractions equal? Are they equal? Okay, so here we go. It is 10 twelfths and 2/3. 10 twelfths and 2/3. And the question is, are they equal or not? Okay, so here's how it works. Okay, here's how I'd like you to attempt this. Okay. Number one, if you know that they're equal, they should simplify into each other. So you can do it one of two ways. You can do this. What are numbers that multiply to give you 10?
2 and 5.
2 and 5, all right? What are numbers I multiply to give you 12? What are numbers?
6 and 2.
6 and 2? Okay. And 2 and 3, I really can't do anything with that, because 2 is just 2 and 1, 3 is 3 and 1. Alright, we can break down this 6 even further, correct? You can break down the 6 even further?
Yep.
What
2
is
and
that,
3.
2 and 3, so you could write this as 2 times 3. Okay. Now, at this point, we're not going diagonally, we're not doing anything like that, because we don't know that these are equal. The whole point is to figure this out. Okay, is there anything top and bottom that I can cancel here? Is there anything top and bottom that I can cancel here?
2.
2's, okay? There's nothing else. Over here, there's nothing, because these had 1s on them, which I could cancel out the 1s, which I didn't really need in the first place. But now at this point, I have 5 over 6, and this is 2 over 3, right? Because there's nothing else I can simplify. Are these the same fraction? No, so you put not equal. In fact, to figure out which one's larger, well, you're gonna do that here in a minute. But do you understand why they're not equal? Because I can't simplify them into each other. Now, to figure out which one's a better deal, which one's the bigger fraction or not. But again, this is how you check if they're equal or not. Okay. How do you know which one's bigger than the other? Here's what you do. You start on the bottom, and you work your way up diagonally, and you multiply those together. So what do you get when you take 12 times 2? 12 times 2.
24.
24. So you get 24 over here. This fraction's value is worth 24. Okay? That's its value when I go diagonally. So now on the other one, I'm going to go diagonally up the other direction. So I'm going this direction. 3 and up. You go diagonally up. What is 3 times 10?
30.
30. That goes over here, right? Because you're going bottom up. Which one's the bigger number, 30 or 20?
30.
30. This fraction's larger. This 10 over 12 is worth more than 2/3.
Cool.
That's how you can figure it out. You just multiply bottom up, and you go diagonally bottom up. And that tells you what your fraction's technically worth. So 10/12 is a bigger number, it's 30 versus 24. So that's a better fraction. But again, you gotta go bottom up. If you forget to go bottom up, you'll never figure it out. Okay, let me give you one. I want to see if you guys can figure this one out by yourself. Okay. Here we go. Let's go with 6 over 8. 9 over 12. Okay, so the question is, are the fractions equal? And if they are not, which one's bigger?
I can already see they're not equal.
Well, simplify. Show me.
This is easy.
Yep. Simplify them. I want to see. What does 6/8 simplify into? So what are the numbers that multiply to give you 6?
72. 86.
3 and 2.
3 and 2. Okay. What about 8?
2 and 4.
2 and 4. Okay. And no door. What about 9?
3 and 3.
3 and 3. What about 12? 6 and 2. Okay. Now, is there any numbers I can break up even further? Yeah, I can break up those 4.
Oh wait, they are equal.
How do you break up 4?
2 and 2.
2 and 2. Okay, so I'm going to break up 4 even further. 2 and 2. How do you break up 6?
3 and 2.
3 and 2. Okay. And now, is there any numbers I can cancel out top and bottom?
3, no, 2.
2's here, so those are gone, so I'm left with 3 over 4. Over here, what can cancel? What, 3's? So 3's on the top, 4's on the bottom, so yeah, these are equal. Now, I did hear the numbers you were doing there, Sam. What was the numbers when you multiplied diagonally? What did you get?
72 and
72, 72, so they're equal. They're the same number, so they are equal fractions. So getting 6 out of 8 on a quiz is the same as somebody getting 9 out of 12 on a quiz. You get the same score.
What is 69% as a fraction?
69% as a fraction, 69 over 100.
Okay.
And you could try to simplify from there, but I don't think there's any further. Okay, questions?
Nope, we're done.
No, got one last one. Last from the day. So last one today.
Bye.
Okay. So the last one today, it's
Bye,
pretty
Mr.
straightforward. Okay.
Maybe fresh breath.
Okay, last one today. Then we're gonna have some assignments tomorrow.
It's a Listerine, but you
We might even play a game tomorrow. We'll see how well you do. Okay. Okay, here's the last thing. I would like somebody to make up a value of money. Any amount of money that you would like.
100, no,
Okay,
1 million.
$1 million? Okay. Say,
I was gonna say infinity.
no, infinity is a direction, not a number.
Oh, see?
So,
Eh.
infinity is a direction. It's not
That
a number.
number.
It represents going larger, it doesn't actually represent a number itself. Something you learn. Alright.
Just smart.
Alright, $1 million. Okay, $1 million. There's this thing that we can use proportions for where we can convert numbers into other values. Let's say you're going to go on vacation. And let's say we're going to go to Canada. Okay? Now there's this website, I'll come up with the website tomorrow. Today I'm just going to use the numbers out of the book here. And we're going to convert money into Canadian dollars. Okay? The Canadian coin. So here's how it works. The Canadian dollar is worth, according to this book is quite old, $1 US, $1 US
That's worth more.
okay, is worth in Canada 1.57 Canadian dollars. This is how they put it as Canada. So if you had $1 US, that's 1.57 Canadian dollars. The conversion rate, so if you went up to a bank and you had $1 in your pocket, they would give you, in Canadian dollars, 1.57. Okay, they're not worth the same amount of money. So, how you do this? This, what you're seeing right here, this is a conversion. This is a proportion, this is a fraction, this is a ratio that you can use. So if you decide to go to Canada with your $1 million, and you're going to live up in Canada, because when you look at the conversion, you're like, whoa, if I move to Canada, they're giving me more money for my dollar than what I have right now. So, we're going to do it. So, $1 US is 1.57 Canadian dollars, correct? That's my ratio. Now, the money you have, is this US dollars or Canadian dollars?
US.
This is US dollars, so you need to put the US on the top. This is $1 million. The reason why, the US money goes on the top, the country you're going to, in our case, Canada, will go on the bottom. Ooh, I switched Canada.
Okay.
Okay.
I'll hate you for that.
Yep.
I'll cook the.
No problem. Alright, so it's full order. Alright, we're gonna convert. So, I'd like you to do your proportion thing. Cross, multiply, and divide. Tell me what you get.
Cross, multiply, and divide.
Multiply and divide. What do you get?
Times 7 times 1. Where's the comma on this thing?
You don't need to put commas.
Do it.
You don't need to put commas. Don't use comma. Commas mean something very, very different.
Divided by 1.
Tell me the number.
Syntax error.
You put commas, you can't use commas. You gotta get a comma out of there. What do you get? Take 1 million times 1.57.
Try that.
Okay, tell me the numbers. Say it out loud. 1,
1, 5,
7,
7, and
Zero.
like 4 zeros.
4,
Divided by.
and then there's holes in the back, right? This is what the bank would give you.
Wrong. 5.
So, if you move to Canada, according to my textbook, which is quite old, and you had $1 million, they would actually give you 1,570 Canadian dollars for the conversion, and that's what you'd have in the bank.
That's good there.
Yeah, let's move.
Now, here's the problem. This was many years ago. This was, I think, 2008.
Oh, so it's not
This
the same
book,
anymore.
so it's not quite the same number. We're going to look at a website tomorrow that will do conversions. There are certain countries where this is nothing compared to what some countries in this
When
world.
you go down the when you come off the Great Wall,
Great Wall of China. There is a country, I think it's Ukraine, in that, you know, the European area it's close to Russia. It's a territory of former USSR. The conversion rate is absolutely ballistic. That when you go to Canada, I think $1 US is almost worth 1,000 of their dollars. So if you went with $1, you'd have $1,000 in your pocket to spend. Okay, to give you an idea of this, I had a couple students, former students that went from the Ukraine for a mission trip. They took $20 and they survived a whole month with $20 in their pocket. So, because the conversion rate was absolutely insane. Buying a burger from McDonald's in Ukraine was 10 cents.
They have McDonald's in Ukraine.
Yep, and it cost them 10 cents to get a Whopper.
Oh,
Or not a Whopper,
yeah.
a Big Mac.
Let's go.
10 cents. They had $20 and they didn't need to break their $20 the whole time they were there.
Just give me the eraser.
You have it even.
It's just the conversion rate was absolutely insane. That's why a lot of people that live in the US that have a lot of money move to a foreign country because the conversion rate is insane.
No, no.
All right,
No, no.
there you go. That's it.